Hello everyone, in today's topic we are going to talk about the power rule and other rules for differentiation. Differentiation is the process of finding the derivative of a function. Perhaps there's an easy way to find the derivative. Let us see. The objective of this lesson is to differentiate functions using the power rule, constant multiple rule, and sum and difference rules. What is derivative? Derivative is used to find the slope of a function at a point. It is used to find the slope of the tangent line to the graph of a function at a point. It is also used to find the instantaneous rate of change of a function at a point. It is computed by finding the limit of the difference quotient as delta x approaches 0 from the limit definition. These are the notations for the derivative of a function. So we have f prime of x, y prime, dy over dx is read as the derivative of y with respect to dx, and dy over dx is the noun for derivative, whereas d over dx is the verb. So it means that we are taking the derivative with respect to x. These are the rules for differentiation. So differentiation is the process of computing the derivative of a function. So you may ask to differentiate, derive, or find the derivative of. So those three words or phrases point to one thing. It is differentiation. The first rule is the power rule. So d over dx, x to the n, equals nx to the n minus 1. So n is any real number. So as you can see, whatever the exponent, it will be the multiplier. And then from your exponent, you need to subtract 1. And remember that d over dx of x, the derivative of x equals 1. So any identity function equals 1. Next is the constant rule. The constant rule states that d over dxc, or any constant, equals 0. So c is a constant. It means that any number. So from negative 0 down to your positive. So remember that under the constant rule, the derivative of a constant function is 0. The next one is the constant multiple rule. It states that d over dx c times f of x equals c times f prime x. So c is a constant. So from here, the derivative of a constant times a function is equal to the constant times the derivative of the function. So if there is a number before your function, you should separate it and get the derivative of that function and then multiply it by the constant. Let's move on to the sum and difference rules. In here, it states that d over dx of f of x plus g of x equals f prime of x plus g prime of x. In here, if there are two functions, you get the function of the first plus get the function of the first. So the derivative of a sum is the sum of the derivatives. But if we have subtraction, so we have d over dx of f of x minus g of x equals f prime of x minus g prime of x. It means that the derivative of a difference is the difference of the derivatives. So first get the derivative of the first function and then you subtract it to the derivative of the second function. So later on, we shall have some examples for this one. Now let us have some example for constant rule. So let us find the derivative of f of x equals 7. So we all know that the derivative of any constant is equal to 0. So therefore, f prime of x equals 0. How about if we have y equals -3? So again, the derivative of a constant equals 0. So we have dy over dx equals 0, or we can rewrite it as y prime equals 0. Now let us solve the power rule. So let us differentiate the following. F of x equals x to the third. So in here, f prime of x equals 3x to the second. So bring down your exponent, which is 3, and then subtract 1 from your exponent. So 3 minus 1 equals 2. So f prime of x equals 3x squared, or 3x to the second. Now let us have another one. Y equals x to the ninth. In here, y prime, or dy over dx equals 9x to the 8th. Let us have another one. G of x equals x to the 100th. Okay, in here, it is equal to g prime of x equals 100 x to the 99. So always, whatever the exponent, it will be the number before your variable, and then subtract 1 from your exponent. So that is power rule. So let's move on to the constant multiple rule. So let us find the derivative of y equals 2x to the 1/3. In here, we are going to separate your constant. So after separating it from your function, get the derivative of your x to the 1/3. In doing this, so it is equal to 1/3 times x to the -2 over 3, because 1/3 minus 1 equals -2 over 3. And then simplifying further so that we are making our exponent positive, it will become dy over dx equals 2 over 3x to the 2 over 3. So let us have another example for constant multiple rule. So let us find the derivative of f of x equals 4x squared over 5. In here, we are going to rewrite this function as 4 over 5 x squared, so that when we separate our constant, we can see that 4 over 5 is the constant. And then after separation, we are going to get the derivative of x squared, which is equal to 2x. And then simplifying further, we have f prime of x equals 8 over 5x. So let us have another one under constant multiple rule. Let us find the derivative of g of x equals 5x to the 7. In here, we are just going to multiply 5 times 7, and then we are going to subtract 1 from 7. So the answer is g prime of x equals 35x to the 6th. So rewriting before differentiating. So in here, there are some functions that we need to rewrite. For example, if we have f of x equals 5 over 2x to the third, so we can rewrite this one as f of x equals 5 over 2 x to the -3. So from here, we are going to differentiate. So to differentiate, we are going to separate 5 over 2, and then we differentiate x to the -3. So the derivative of x to the -3 equals -3 x to the -4. And from here, we are going to make our exponent positive. So we simplify. So the final answer would be f of x equals -15 over 2x to the 4th. So that is rewriting before differentiating. Now let us have another one. So g of x equals 7 over 3x to the -2. We can rewrite this one as g of x equals 7 over 3 x to the second. So from here, we can differentiate. So we have 7 over 3 times 2x because the derivative of your x squared equals 2x. And we can simplify. So simplifying further, g prime of x will be equal to 14 over 3x. So that would be the final answer. 14 over 3x. Now let us have another one. H of x equals square root of x. In here, we can rewrite square root of x as x to the 1/2. And from here, we can differentiate. So h prime of x equals 1/2 x to the negative 1/2. And then simplifying further, making our exponent positive. So our h prime of x equals 1 over 2 x to the 1/2. So let us have another one. J of x equals 1 over 2 cube root of x squared. From here, we can rewrite it as j of x equals 1 over 2 x to the 2 over 3. So remember how to convert radicals to exponential function. So in here, we can also rewrite it as 1 over 2 x to the negative 2 over 3 so that we can apply differentiation. So separating 1/2 and then getting the derivative of x to the negative 2 over 3, we have j prime of x equals 1/2 times negative 2 over 3 x to the negative 5 over 3. From here, we are going to make our exponent positive. So the answer would be j prime of x equals negative 1 over 3x to the 5 over 3. So now let's move on to sum and difference rules. So let us have some examples under this rule. Let us differentiate f of x equals 5x squared plus 7x minus 6. In here, f prime of x equals 10x plus 7 because minus 6, the derivative of minus 6 or negative 6 is equal to 0. So let us have another one. G of x equals 4x to the 6th minus 3x to the 5th minus 10x squared plus 5x plus 16. In here, let us differentiate one by one. So j prime of x equals 24x to the 5th minus 15x to the 4th minus 20x plus 5 because the derivative of 16 equals 0. So need not to write it. So the final answer is g prime of x equals 24x to the 5th minus 15x to the 4th minus 20x plus 5. So let us wrap up what we have learned today. So these are some of the notations for the derivative. F prime of x, y prime dy over dx. And to get the derivative of a constant, it is always equal to 0. And to find the derivative of f of x equals x to the n, first we are going to pull a copy of the exponent out in front of the term. And the next one, subtract 1 from the exponent. So that's it for now. Thank you for watching. See you again next time. Bye.